Bismillahirrahmanirrahim. In the previous lectures, we have discussed the disorders of white cells, benign disorders, leukopenias, that means decrease in the number of white cells, and proliferative disorders, which include the reactive proliferations. Today we will discuss the neoplastic proliferation of white blood cells. So, three major categories we can classify these tumors. Number one is lymphoid neoplasms. These may belong to B cells, T cell, B cell means B lymphocytes, T cell, T lymphocytes are natural killer cells. And second major category, that is myeloid neoplasms. Myeloid neoplasm means the tumors will arise from these cells normally produced in the bone marrow. Most important of these are acute myeloid leukemias, myelodysplastic syndrome, and chronic proliferative disorders. Similarly, we can have some tumors of the macrophages. These are known as histiocytosis, Langerhans cell histiocytosis. This is a Langerhans cell. This is some immature dendritic cell. We can see this type of tumors, although these are rare. So, we will be discussing these inshallah in the next lectures. What is the etiological and pathogenetic factors? Chromosomal translocations and other acquired mutations. This is seen in most of these cases. The genes that are mutated or otherwise altered often play crucial roles in the development, growth, or survival of the normal counterpart of the malignant cell. So, these proto-oncogenes, normally they were controlling the development, growth, or survival of the cells. When there is some mutation in these genes, so these will result in changes in these characteristics. So these may be in two ways, maybe loss of function, maybe gain of function. We will be discussing this in bit detail. Oncoproteins created by genomic aberrations often block normal maturation. So this is one characteristic. Due to these mutations, the normal maturation may be arrested at any stage. So this arrest in differentiation plus self-proliferation. So we can see this mainly in acute leukemias, acute lymphoid neoplasms. So BCL6, you can see this, its role in germinal center B cell proliferation, which include the reactive proliferations. Today we will discuss the neoplastic proliferation of white blood cells. We can discuss this in detail. You can see from this picture, we can say upper one, normal cell. There is some regulated proliferation and some regulated apoptosis. The lifespan of the cells is limited. So we can see two types of factors controlling these characteristics. There are some normal proteins, we call them proto-oncogenes, they will release some transcription factors which will regulate the proliferation and apoptosis of these cells. Just like we are driving a car, so when we press on the accelerator, so this will get the speed. But for a proper controlled driving, we must have intact brakes. We can consider this tumor suppressor gene. There are some other proteins which will limitate, which will act as brakes. These will not allow the uncontrolled proliferation. So, in a normal cell, under the action of these proteins, proto-oncogenes and the tumor suppressor genes, there is a regulated proliferation, regulated apoptosis. The lifespan of the cells is limited. Now, due to different factors, these may be in the form of some chemicals, radiation, maybe some drugs, especially chemotherapeutic drugs, maybe some viruses, maybe some changes in the chromosome, translocations in the form of deletions or other chromosomal changes. Now, due to these different factors, there is some change in these proteins. So, this may be in two different ways. Proto-oncogenes, the changes in such a manner that they are overexpressed. Their activity is increased. Now we call them oncogenes. Now this will result in excess proliferation and failure of apoptosis. Similarly, opposite to this, if the brakes fail, if the tumor suppressor gene, the mutation in the chromosome is such like this will suppress the function of tumor suppressor genes. These are inactivated. That means the brakes are failed. So again there will be uncontrolled proliferation and failure of apoptosis. So this is the simple way to explain these malignant changes. This picture is from Essential Hematology. I think this is very easy to understand from this picture about the pathogenesis of malignancy. Now this is from your book Ribbons. Now these are, due to these changes, there are three characters which are changed. One character is increased self-renewal. Some transcription factor really, these will give equality to the cell at any stage of development, that this can like stem cells, this can renew itself. So this achieves some special quality of self-renewal. Sometimes these changes, these will result in overexpression of the tyrosine kinases. These mutations, for example, BCR and ABL, in Philadelphia chromosome, in chronic myeloid leukemia, we see this change. And after this change, the tyrosine kinase activity is increased. This results in increased growth and survival. So nowadays, tyrosine kinase inhibitors are used for the treatment of this type of malignancy. Another characteristic, that is, some mutations will result in the arrest of differentiation. Now, the differentiation and maturation of the cells is arrested, and at the same stage these are multiplying continuously by mitotic divisions, and these will replace the normal cells, and we can see this type of picture in acute leukemias. The immature blast cells are replacing the normal myeloid elements in the bone marrow, and just this results in acute leukemia. Now there are some other factors related for the causation of cancers, malignancy. Some are inherited genetic factors, for example, in Fanconi anemia, Down syndrome, in neurofibromatosis, ataxia telangiectasia, different diseases. In these, the genetic makeup of the baby is like this, that they are prone to get more mutations due to different environmental factors. So they have an increased incidence for getting different types of malignancies, especially leukemia. Another thing which is involved, that is the viruses. Different types of viruses are incriminated for the causation of leukemia. Human T-cell leukemia virus, HTLV1, and this is suppose that this is the cause for adult T-cell lymphoma or leukemia. Similarly, Epstein-Barr virus, EBV, this is seen in a special subset of Burkitt's lymphoma. Most of the patients have this viral infection. In 30 to 40% of Hodgkin lymphoma, especially some other types of large cell lymphoma, we can see these viral infections. Similarly, human herpes virus 8, this is incriminated for the causation of Kaposi carcinoma. Now another cause may be chronic immune stimulation. If there is some chronic inflammation, so there may be some changes in this inflamed area. For example, H. pylori, this is a bacteria, this bacterial infection in the stomach. This is incriminated in the causation of gastric B-cell lymphomas. Similarly, gluten-sensitive enteropathy, intestinal T-cell lymphomas. In these conditions, there are more chances due to chronic inflammation in this inflamed area, we can get this malignant change. Similarly, HIV, advanced disease of AIDS, there are more chances to get B-cell lymphoma. Another thing is iatrogenic factors. For example, patients who are treated by radiations or chemotherapy, they produce some mutations in the chromosome, and these patients have an increased tendency to get different types of tumors, especially leukemia. Similarly, smoking, there are some carcinogenic factors in the smoke, in the tobacco smoke. One of these is benzene. These persons are exposed for these carcinogens, and it is estimated they have more chance to get the tumors. Now this is about the pathogenesis of tumors. Now we will discuss different types of lymphoid neoplasm. Now this may be in the form of first the involvement of bone marrow, then this come in the peripheral blood and then goes to the lymph nodes and other organs like spleen and liver. So we call them lymphocytic leukemia. Although in our new classification these may be too much overlapping or same diseases, but for clinical purpose these are still used. Leukemia will first involve the bone marrow, then this will come in the peripheral blood, then this will invade the other tissue. Lymphocytic lymphoma. Most of the time this will involve the tissues, then this can invade the bone marrow, and again this can come in the peripheral blood and lymph node. So just clinical presentation we can see, otherwise in new classification by the help of these markers, now they are saying that these are the same diseases. The important thing is what is the stage of the cell where this change occurs. But still in clinical practice this division is considered. Now classification, different characteristics of the cells like morphology, immunophenotyping, genotyping and clinical features. All these things are used, and then a group of pathologists working under the umbrella of World Health Organization, they have agreed on this classification. This has been a very big controversy for years and years for the classification of lymphoid neoplasm. But now they have agreed on these points with the improvement of immunological markers. We can recognize the stage of cell development where the change is occurring. Now they divide these lymphoid neoplasm like this. Number 1 type, precursor B cell neoplasm of the immature B cells. Then peripheral B cell neoplasm of the mature B cells. Number 3, precursor T cell neoplasm of the immature T cell. Number 4, peripheral T cell and natural killer cell neoplasm of the mature T cell and natural killer cells. Number 5 is Hodgkin lymphoma. This is special type neoplasm of Reed-Sternberg cells and its variants. So we can say this is major classification. Now for each we can have different group of diseases. Precursor B cell neoplasm from the immature B cells, one can have B cell acute lymphoblastic leukemia, ALL, most common ALL we say in clinical practice. This is most common in the small children between the ages of 3 and 10. We will be discussing this in detail. This is the most common of leukemia in young children. Acute lymphoblastic leukemia or lymphoma. Now they are considering the same. This is BALL. Then peripheral B cell neoplasm. One can have chronic lymphocytic leukemia, CLL, most common thing in old age people. Splenic and nodal marginal zone lymphomas, extranodal marginal zone lymphoma, mantle cell lymphoma, follicular lymphoma, hairy cell leukemia, plasma cell myeloma, diffuse large B cell lymphoma, Burkitt's lymphoma. So this classification is given in your books. You can memorize this. We will be discussing important of these next lectures. Number 3 is precursor T cell neoplasms, immature T cells. We can have T cell acute lymphoblastic leukemia or lymphoma, TALL. Number 4 is peripheral T cell and natural killer cell neoplasm, T cell pro-lymphocytic leukemia, large granular lymphocytic leukemia, mycosis fungoides or Sézary syndrome, peripheral T cell lymphoma, unspecified, anaplastic large cell lymphoma, adult T cell leukemia lymphoma, extranodal natural killer cell or T cell lymphoma, natural killer cell leukemia. Now next is Hodgkin's lymphoma. We have different categories. One most in classical Hodgkin lymphoma. In this classical Hodgkin lymphoma, we have nodular sclerosis, mixed cellularity, lymphocyte-rich, lymphocyte depletion types, 4 types in classical Hodgkin lymphoma. Another variant is nodular lymphocyte predominance Hodgkin lymphoma. We will be discussing these tumors in next lecture. Now, how will diagnose? For leukemias, we can diagnose these cases from the peripheral blood, CBC, simply. In very early stages, maybe THC within normal range or even below normal, very rare last, we can do the bone marrow aspiration and we can see the bone marrow. This is replaced by the immature blast cells. If there is lymphadenopathy, we can do histological examination of the lymph nodes, or if there is some tumor of some tissue, we can do this. Nowadays, we can do this FNA for the lymph nodes or for some tissue. So from these tests, we can recognize the vast majority of the lymphoid neoplasm are of the B cell origin, 85 to 90%. Most common in the children, that is precursor B cell, acute lymphoblastic leukemia. Lymphoid neoplasms are often associated with immune abnormalities. When this malignant change occurs, so immunity of the person will be deranged. Another characteristic of these neoplastic B and T cells, these tend to recapitulate the behavior of their normal counterparts. For example, T cells, where these are lying, after even malignant change, the cell will behave like in a similar way. They will go to the skin, for example, in the most of the sick malignancy of the skin lymphoma, these are the T cells. Similarly, B cells, they will behave like their original cells. Hodgkin lymphoma spreads in an orderly fashion. This is special for the Hodgkin lymphoma. This will spread to the nearby lymph nodes. So initially this was used. We will discuss in detail in this topic. There was staging of the lymphoma. The treatments were different for different stages of Hodgkin lymphoma. according to the spread of the disease. Another feature, antigen receptor gene rearrangement. This precedes the transformation. And the result is same antigen receptor gene configuration and sequence we can see in the next cells. That means the colonial proliferation. And these cells will synthesize identical antigen receptor proteins. These proteins may be in the form of immunoglobulin or T cell receptors. So these transformed cells, after this transformation, they will produce identical cells, and these identical cells will be producing the identical proteins. From this picture, from your book, you can see this, where these cells are lying in the bone marrow and the lymph nodes and the thymus, what is the normal place, and after malignant change, what type of tumor they will give rise, and their behavior, as we have discussed, they will try to maintain their previous characteristics. So this is general description of the lymphoid tumors. Inshallah, next we will be discussing in great detail about individual tumors.